Welcome back, and we're moving on with types of reactions in organic chemistry. And now quickly let's have a look at hydration. Hydration, you are adding water molecule. Okay, this is the addition of water molecule. Obviously, addition reaction happens to such unsaturated hydrocarbons. So let's say you've got that one there. You've got ethene again. So you adding a water molecule. All right, what are we going to see happening here? Allow me to have that arrow like that here. So that other bond breaks again. You've got, allow me to have the open spaces the side here, and then you've got your H here. Okay, got your H there, H there, H here, and then you've got the H there. Those open spaces, H can go there, and you've got the OH coming there. So in other words, you've got that happening there. Again, this would be some this is addition reaction, and we call it hydration because you are adding a water molecule. Moving on to other types of chemical reactions involving organic molecules, let's look at elimination reaction. Here we have got dehydrogenation. In other words, you're getting rid of hydrogen. D means removing. So if you had, for example, this one, you had ethene, an ethene molecule like that. Okay, and you subject it to some heat and use certain other catalysts and other substances to force it to get rid of the hydrogen gas. What you're going to have is you're going to form an alkene, which in this case is ethene, an unsaturated substance, and here the two hydrogens that have been removed, dehydrogenation, removed, would form that hydrogen molecule there. Remember, you are removing two hydrogen atoms. They come together, they give you your hydrogen molecule, the H2, but I'm writing it in a structural form there. Okay, dehydrohalogenation, it's the reverse of what we have looked at, like we have seen here. Look at that. This, you need to have a haloalkane in the first place. Okay, so let's make use of that one. And if you remove that, okay, you remove that, it's dehydrohalogenation. You are removing a hydrogen and a chlorine. So you would form the HCl there, and then what is forming here is again your ethene molecule, okay, an unsaturated hydrocarbon like that. Dehydration means you are now removing water. Okay, removing water, look at, you would need an alcohol to remove the water from, like we saw earlier on. So let's look at ethanol, which is the alcohol in most of our alcoholic beverages. So you remove that water molecule because this is dehydration. So you've got double bond again there, and then you form ethene. So that's ethene, and from this you are forming the water molecule. Okay, so that's what you have. Right, moving on, formation of esters. Now this is quite interesting. You need an alcohol and a carboxylic acid to produce an ester, and when you're producing an ester, one of the other product formed or byproduct is it's actually water. Okay, now let's have a look at it. If, for example, you've got ethanol reacting with methanoic acid, okay, you will produce ethyl methanoate. Check where the ethyl comes from. It comes from the alcohol. The acid gives you the OH side, which is the ester, ethyl methanoate, plus of course the water. Now, how does that happen? Let me just use structural formula here. Here is ethanol. Okay, quickly, ethanol. And then you bring in methanoic acid. So allow me to write it this way and say C double bond there, say O there like that. Okay, so this is O, H, bond O, bond C like that. That is methanoic acid. Now what happens is that this part here breaks up to give you your water molecule, H2O. Now this other part here, where does it go? Let me use this space here. Then you've got that. Here is your part of the alcohol. Okay, there is this O here, H, that O there to oxygen, to carbon like that, double bond there, and then you've got your hydrogen there. This is then ethyl. This is then ethyl, this ethyl, and methanoate. Okay, methanoate. All right, hope you enjoyed that. Keep well, see you next time.